Hi, welcome to our video. Today we are gonna talk about surface tension measurement by floating a needle on the surface of different liquid. We can find many fallen leaves float on the surface of water during the fall. Sometimes we can observe a water strider or some other insects which are even denser than the water, unable to walk or stride on the surface of water, just like people walk on a trampoline. This property of water is known as surface tension, which allows the surface of water to behave as a trampoline. On molecular basis, surface tension results from the greater cohesion of water molecules to each other than the adhesion to air molecules on the surface of the water. Within the liquid, a liquid molecule is surrounded by the other liquid molecules on all sides, and thus is attracted equally in every direction by its neighboring liquid molecules, leading to a net force of zero. In contrast, since there is no liquid molecule above the liquid surface, a liquid molecule on the surface experiences a net attractive force pointing toward the liquid interior. This generates some internal pressure of liquid and forces the liquid surface to contract to minimal area. Water strider can walk on the surface of water. Is water strider still able to walk on the surface of other liquid, just acting as on the surface of water? We thus come up with a hypothesis that different liquid solutions have different surface tension at room temperature or any other certain temperature. Surface tension gamma is defined as the dimension of force per unit length. As shown in this figure, the needle's weight W and the two forces F1 and F2 due to the surface tension of liquid act on the needle, and the balance of these three forces makes the needle stay on the surface of the liquid solution. The sum of the vertical components of F1 and F2 balances the weight of the needle, and the net force on the needle is zero. We aim to calculate the surface tension of water, olive oil, and ethyl alcohol at room temperature by using the equation shown here. Then we compare the calculated surface tension to the corresponding theoretical surface tension values for further error analysis. The material we used in our experiments are needle, scale, ruler, protractor, water, olive oil, and ethyl alcohol. In order to minimize the measurement error made by the scaling process, we weighted 100 needles at one time and divided the total weight by 100 to get the average weight of one needle. The weight of a needle we used in our experiments is 0.036 grams. We used a ruler to measure the length of the needle. The measurement will be repeated for 3 times to get the average length of the needle. The length of the needle in our experiments is 3 centimeters. We put the needle on the surface of water. We put the needle on the surface of ethyl alcohol. We put the needle on the surface of oil.
Then we took the picture of the rear view of the needles after they stay static on the surface of liquids. Then we used a protractor to measure the angle of theta 1 and theta 2 and took the average of them. You may notice that the needle stay on the surface of oil will sink instantly. It is because the needle get wet on the surface of oil. Then we use screenshots to take the picture of the rear view and measure the angle. After we got all the angles, we can calculate the surface tension. The following table shows the calculated surface tension in millinewton per meter. Respectively, water is 64.9, and olive oil is 30, and ethyl alcohol is 20.3. We also compared our calculated value with the theoretical value and calculate the relative error, as shown in the table. So we can see that water has the largest surface tension and ethyl alcohol has the lowest, while olive oil stay in the middle.
Thanks for watching.